Hello everyone, welcome to NathCorp Spotlight series. So today we will discuss about Wireshark MCP. So before start the sessions, let's think. What if instead of digging through thousands of packets in Wireshark, you could simply ask in plain English, is anything suspicious happening on my network right now? And get a clear answer back in seconds. That is exactly what Wireshark MCP aims to do, combining network traffic analysis with AI using Model Context Protocol to make our investigations faster and easier. Okay, so today we are talking about AI driven network analysis. So in this session, I'll first introduce MCP, then show how Wireshark integrates with it, walk through the architectures and tools, and finally do a live demo of AI interacting with real network traffic. Okay, so let's begin. So before we move, here is a quick look at what we will cover today. So first we will understand what model context protocol or MCP actually is, because that's the foundations behind everything we are doing. Then we will see how Wireshark connect with MCP and how that integrations works. After that, we will look at the capabilities available inside the tool and what AI can actually do during analysis. And finally, the most interesting part, we will move to a live demo and see AI interact with packets analysis in real time. Okay. So the goal is today not just to show a tool, it's a different way of thinking about network analysis and making it faster, simpler, and more attractive. Okay. So let's start with basics. What is MCP? Think of it like a power plug. Your AI is a device, MCP is the plug that connect it to the real world. Without MCP, AI only knows the things it learned during the training, like old static information. With MCP, I can talk to live tools, run actual commands, and read real data happening right now on your network. Imagine you hire the smartest network analyst in the world. Brilliant. They know everything. But they are locked in a room with no computer, no internet, nothing. That is AI without MCP, smart but blind. MCP opens the door and hands them a keyword. Now they can actually do the things, run commands, read your live network, check files, everything. But there is one most important point, like the AI never directly touch your system or environment. It send request to the MCP server. The MCP server decide what is allowed, perform the action, and return the results. So MCP act as a communications layer between AI and the real world system. So it is an open source framework introduced by Anthropic in November 2024, and it works the same way across any MCP compatible client such as Claude desktop. In our case, Wireshark becomes one of those connected tools. Instead of user opening Wireshark and manually running filters and analysis, AI become the operator and MCP become the bridge that allows AI to work with packet analysis. Okay. Now let's understand why this is important, especially for network analysis. Think about the traditional way. We open Wireshark, start a packet capture, wait for 10 minutes, export a file, apply filter one by one, and then inspect packets manually. That process can easily take hours, and the bigger challenge is you already need networking knowledge to even know what you should looking for. Now imagine a different approach. Instead of doing all that manually, you simply ask, is anything suspicious happening on my network right now? The AI handles the heavy work. It captures traffic, applies filter, analyzes output, and gives back a simple explanation. For example, it could tell you your laptop is connected to an unknown server every 60 seconds. Same data, same investigations, but now instead of spending hours, we get answer in seconds. And instead of requiring an expert, it becomes accessible to more users. AI can automate repeated analysis, provide faster feedback, and help reduce human mistakes. So instead of memorizing Wireshark filter, user can simply ask questions like show unusual protocol, identify suspicious traffic, explain this packet. So the goal is to help them reach answer faster and make network analysis easier. Okay. Now let's see how everything works together. Think of Wireshark MCP as a bridge between AI and network. On one side, we have the AI. On the other side, we have TSAR, which can actually read network packets. When I ask a question like, is anything suspicious happening on my network? The AI understands the questions, but AI cannot read packets by itself. So it sends the request to the Wireshark MCP server. The MCP server acts like a bridge. It takes the AI request, convert it into the correct TSAR command and runs it. Then TShark analyzes the packet capture and returns the raw result to the MCP server. The MCP server sends those results back to the AI. Finally, the AI convert all the technical packets data into simple English explanations that anyone can understand. So here TShark is simply the command line version of Wireshark. It has the same packet analysis capabilities, but because it's command line based, AI can control it automatically. So that's why we use TShark instead of Wireshark graphical interface. Okay. So this setup support two deployment options. Local mode is for running everything on your own machines. HTTP mode is useful when you want to host the MCP server and allow multiple users or applications to access it remotely. Okay. So the overall flow is very simple. Like we ask a questions, AI send the request, MCP act as a bridge, TShark analyzes the packets, and AI give us the answer in plain English. So the user does not need to read thousands of packets anymore. They simply read the explanations. Okay. Now let's look at what happens behind the scene when someone asks a question. For example, imagine I ask, is there anything suspicious on my network? The request first reaches the MCP server. The entry point here is run.py. Its job is simple, like it start with server either in local mode or HTTP mode. Once the server is running, the request goes to server.py. You can think of this as the control room. It knows all the available tools and decide which one should handle the request. If the request needs packet analysis, it forward it to the TShark wrapper. This wrapper does not execute command directly everywhere. Instead, every TShark command goes through one central execution point using subprocess.run. Having one execution path makes the system easier to manage and more consistent and safe. At the time, config.py provides the settings like where TShark is installed, how long a command can run, and the maximum number of packets to process. So the complete flow is very straightforward. The AI receives the user questions. The MCP server selects the right tool. The tool runs the required TShark command. TShark analyzes the packets and return the result as structured JSON. Finally, the AI reads the JSON and explains the findings in plain English. So the important thing is to remember that the AI is not making assumption. It's reading real packet data, analyzing the actual results, and then explaining them in a way that's easy to understand. Okay. Now let's move to the capability layer. There are the tools we have defined inside our server. So basically these are the tools that we have defined. Each tool has one specific responsibility. The interesting part is that users don't choose the tools, the AI does. Based on the questions, AI decide which tool to use and in what order. For example, if I ask, is there anything suspicious on my network? The AI might first identify the protocols, then search the packets, then check traffic statistics, and finally analyze the behavior, all automatically. Let's quickly look at what each tool does. So first we have capture live. So it captures live network traffic from the system, so the AI works with real-time data. Get protocol. tell us which protocol are present like HTTP, HTTPS, DNS, TCP or UDP. So it gives us a quick overview of the traffic. Search packet is used to find specific packets based on the things like an IP address, port numbers, protocol, or even a keyword. Get conversation shows who is talking to whom on the network. It helps us understand the communications between different systems. Follow stream rebuilds an entire conversations between two devices. So instead of looking at individual packets, we can see the complete data exchange. Get statistics provide a high level summary of the traffic, like the busiest IP addresses, bandwidth uses, packet counts, and overall network activity. Finally, we have analyze behavior tools that looks for unusual or suspicious patterns in the traffic and provide security related insight. The important thing is that every tool return its output in a structured JSON format, and that makes it easy for the AI to combine results from multiple tools and build a complete answer. Okay, let's quickly recap. First, by combining fast MCP with TShark, we create a lightweight but powerful bridge between AI and network traffic analysis. Second, the AI does not rely on fixed workflow. It automatically chooses the right tool and combine them to answer the user questions. And third, analyze behavior is the next major step. The goal is not to just collect and display network data, but to automatically detect suspicious behavior and provide meaningful security insight. Okay, so that's the architecture and the tools behind the Wireshark MCP. That's how everything fits together behind the scene. Now let's move to the most exciting part, the live demo, and see Wireshark MCP analyze real network traffic in the real time. Okay. All right. Now that we have seen how Wireshark MCP is built, let's actually see it in action. This is a completely clean setup, no shortcuts, no pre-built environment. So I'll spin a Wireshark MCP from scratch right here. So I've already cloned the GitHub repository. You can find the repository link in the description. And I am currently in the project main folder. Okay. So the first thing as a best practice is we have to create a virtual environment so that this keep all our dependency isolated from the rest of the systems and nothing gets messy. And then we have to activate it. Just run this command and see we are inside the virtual environment. That little .env tag at the start of the prompt confirms it. The second thing we have to upgrade our PEEP. So just quick PEEP upgrade just to make sure like we are not finding any versioning issues later. It will take like 2 to 3 seconds to complete the installations. And here you go. It's successfully installed PEEP 26.1.2. Now the next thing we have to install the requirement, all the libraries and dependencies. So from the requirement.txt file, we will install everything. So this will pulling the fast MCP, Pydantic, Vicon, cryptography libraries, all of the dependencies and libraries that will required for Wireshark MCP to talk to an AI model. So basically it is an entire backbone that lets Wireshark talk to an AI model. Okay. So it will take 2 to 3 minutes to complete the installations. Let's wait for 2 to 3 minutes to complete the installations and then we will move forward. Okay. And there we go. Everything installed cleanly and we are good to go. Now let's try to start the MCP server. So first I'll run it on studio mode. So this is the mode we would use when Claude Desktop talks to locally directly on your machines. Okay. So let's press hit enter. Perfect. Now you can see our Wireshark MCP start running. We can see the server name, the fast MCP 3.4.0, and we can see starting MCP server, our Wireshark MCP server with transport studio. Okay. So if you want to stop it, we can simply press Control C and it will stop server gracefully. Now let's try the other transport mode, the HTTP one. So this is what we would use if you wanted to run this remotely in the cloud or expose it to other systems. Okay. So here we will use the HTTP and hit the enter and it will start the server. We can see UV on is running on port 8080. So just to be very clear here, like same server, same tools, two completely different ways to connect to it. That is the flexibility built into MCP. Okay. So if we want to stop, we can do the same process like Control plus C and then it will stop the server. Okay. Okay. Now let's connect our MCP server with Claude Desktop. So I have opened Claude Desktop. So you can simply click on your profile, go to settings, and then click on developer. And here you can see I have already added my Wireshark MCP and it is currently in running state. So to add MCP server, we have to click on edit config. And then we have to open the Claude Desktop configurations. It will open a JSON file. Here we have to provide our Wireshark MCP detail and close the file and restart the your Claude Desktop. Here we can see the Wireshark as a local connector added and system prompts and network references, all of that. From the manage connectors, we can see all the tools inside that Wireshark MCP. Okay. So let's type a prompt and see how it provides a response. So I'm going to ask it to analyze a real packet capture completely in plain English, analyze the PCAP file, and list all detected protocols with packets count. See, it's first finding tools like get protocols, get statistics automatically without telling me what to use. So here we can see the capture overview, total frames, total byte, capture durations, and the detected protocols and packet counts, all of that. And then we can see the key observations like LDAP dominance, DNS activity, TLS present, ERF traffic is vary, and in the last, like we can see the summary, the overall summary of that packet. Now let's try another prompt. Like, is there any suspicious in this packet? And let's see what it says. So it will again analyze the behavior, finding tools, and get conversations, call the tools, search the packets. It will do automatically. You don't need to mention like use this tool and all of that. So it will provide the response based on its reasoning. So here it's provide the most critical thing like print credentials and LDAP bind found in that particular PCAP. We can see the username and password in clear text. And then we can see the critical server rejected the bind due to missing encryptions. And then we see like high failed DNS server lookups for 80 sites. And then there is a medium issues that external TLS connection to public IP, and then one like medium LDAP users instead of LDAPs. Okay, and based on the details, it will also create a summary table. Like you can see the severity and the findings, like critical plain text password, critical client send credential despite server require encryptions, high, medium, and medium. And the best part is that it also provides the recommendations like enforce LDAPS, rotate the password, navigate the user IP, fix DNS, decide configurations, all of that. Okay, now everything so far has been analyzing an existing file. So let's go live. What if you want to capture the live traffic? So I'll just provide the command like prompt capture network activity and summarize what website services or application seems active. So it will do the reasoning, call the tools, loaded the tools, and it provide the response. So here you can see the interesting thing that it will ask for to select the interface. So we will select the Wi-Fi interface. So based on the Wi-Fi interface, it will capture the traffic that is currently going on Wi-Fi interface. So it will capture the live traffic. So it will take like 2 to 3 seconds. So it is capturing the data in live. So here we can see like capture live, search packets. And again searching the packets. And here you go. We got the response. The full summary of what was detected across 501 packet capture over 30 seconds on your Wi-Fi interface. So we can all the services running in the Wi-Fi traffic like RDP, Microsoft Azure Teams, on Microsoft Azure RDP connections, all of that. Google services, Cloudflare, external HTTPS, local network connectivity, everything. And it also break down the protocol and notable findings, and it provide like what is this machine is primarily connected to, like Microsoft Teams, active RDP sessions, all of that. We can see everything, whatever traffic going on that particular interface, the Wi-Fi interface, and it captured everything and provide the summary of all of that. Okay. One more thing before we wrap up. What if we want to keep this capture for later analysis? So let's write a prompt like capture live traffic for 20 seconds and save the capture for later analysis and see what it provide the response. So it will start capturing live traffic again. So it will take again like 2 to 3 seconds to capturing the traffic because it's captured the traffic in live mode. So it is working. Let's wait for the response. And done. Here's a quick summary of what was captured and saved. Here you can see the capture file is saved on D drive. Provide the file path locations where it is saved, and then we can see the capture snapshot, whatever the traffic currently active, top active connections like Microsoft Azure VM, Teams, Claude, Google Cloud, Cloudflare, and it's also mentioned the RDP sessions, all of that. And the file is ready. Like whenever we need it, we can download it for different analysis in Wireshark. and we can save it directly in Wireshark. Okay, and that is the Wireshark MCP in actions. From a completely cold setup to a working AI-powered network analyst, connected directly into Claude desktop in just a few minutes. So thank you so much for watching this NathCorp Spotlights episode.